Training and building neural networks means dealing with a lot of unintuitive parameters. So I've built this app to approach understanding neural networks in a more visual way. Now on the left hand side we have where we can build the network. The plus means that we can add a dense connected layer, and we can also remove them. We can add as many as we want, and they will be there. At the top we have some global options like the optimizer, which we have 4 choices. The loss function, which for now is just 1. We have the learning rate and the epochs that can be adjusted. So I'll go ahead and add 2 layers. I'll do 32 to 16 neurons. I'll keep it as ReLU and He initialization for now, and I won't touch dropout rate or L1 and L2. Now I'll go over here, and right now we can only train on MNIST dataset, and we can adjust the batch size to make it run a little quicker. Change it to 100 and just reduce the validation split. Okay, now when we train this, we'll see that we get lots of stats on screen, and we get a graph of training loss versus validation loss. Now this is very helpful to see when the model starts overfitting. As we can see, training accuracy is increasing very quickly. It's almost at 100%, while the validation loss is increasing significantly and the accuracy is decreasing, meaning our model is overfitting to the data too much. And we also get a log of everything that's going on. And actually, if I just train this again, while it's training, you can change things. Like, say I can change the epochs, say that was way too many, and I only want 50. Maybe I want more now. Or I could change the learning rate if I think I'm getting closer to a local minima. Now I will change the optimizer. I'll change it to Adam. And with Adam, as you would probably find out in this program very quickly, Adam works a lot better with a smaller learning rate. And we can click this button to get the advanced parameters, which for Adam is beta 1 and beta 2. I'll just keep them as the default right now, and I want to make the network more complex, so I'm going to try 64 to 32. Now I'll keep everything else the same, and I'll train it. We see pretty quickly it's reached a decent accuracy, and as it's going, I'll just reduce the learning rate. Now we seem to be getting stuck at about 97.4% with a very high training accuracy, showing there could be signs of overfitting. And if we just go to the right, we can see that we can actually test against all 10,000 samples in our dataset. We can see that we get 97% accuracy. And we could go through them all and look at, sample number 5,505. It was a 0, and it got it correct. Now what's interesting is we can add our own input. So I could draw a 2, which hopefully it'll get it correct, because that's quite a simple looking 2, which it did get with a confidence of 1. And just to the right of that, we can see a saliency map, where we can click on one of these pixels, and it will tell us the saliency. And the saliency is how important a pixel was in the final outcome, in the final decision of the neural network. So red meaning that it was very important, cold blue meaning it was very important in the other direction, and a white, yellower, more neutral color means it didn't matter too much. Now what's interesting from just playing around with this program is that I found that more complicated networks have a less understandable saliency map. a smaller network. Let's try just 16 to 8, and I'll train it for a little bit. Now it might not get us as good accuracy, but if I predict this, you can see that the saliency map is starting to look a bit more, it's not really looking like a 2, but you can see there's some kind of pattern going on in it. So that's one of the things that I've found interesting from just playing around with this. And so I might go ahead and try and make something quite a lot more complicated. Maybe 128.64. Maybe I'd add another layer. And I'll just reset this to that. And I'll click train. We can see so far that validation accuracy is kind of hitting a plateau, and training accuracy is still increasing closer and closer to 100%. So maybe if I reduce the learning rate, it might give us a slight boost in validation accuracy, but that's probably going to be the max that we're hitting. So if we test it, 97.5%, that's all right, but we are noticing a little bit of overfitting here. So I might go ahead and increase the dropout rate just a little bit, just on a few of the layers, and maybe I'll get a bit of L2 regularization going throughout the network and see how that performs. And we can see that as we get closer, training accuracy and validation accuracy are quite similar, showing that there's much less overfitting going on, and that instead of just mapping to the training data, we are coming across some kind of genuine, useful relationship. If I check that, yeah, it's 2 with high confidence, and actually the saliency map is, there are some cool patterns going on. And if I test it, nearly 98%. So with this kind of setup, from my testing, roughly about 98% is on the higher end of what you can get. Now, the code for this is open source on GitHub, and I think it could be useful for understanding simple neural networks with dense layers. So I hope from this video you know how to use it, and you might have a mess around with it yourself.